Since the 20th century, the industry development has propelled urbanization. However, municipal waste pollution is becoming increasingly serious. Currently, about 10 billion tons of waste is produced annually all over the world. 6 times the global grain output, 14 times the steel output. However, dumping and landfilling is still the mostly used way of waste disposal, which encroaches on the land, stinks and produces a large number of pollutants such as bacteria, virus, methane, ammonia, and sulfide. Besides, the leachate produced by landfills is polluting the groundwater in the long run. Landfill is harmful to us and the later generations, so it becomes obsolete in more and more countries. Waste is misleading resource. How to manage waste properly and transform waste into useful products in a circular way is an important issue of considerable global concern, needed to be addressed promptly. To handle waste in a scientific and environmental friendly way can not only improve ecological environment, but create economic benefits. We have been devoting ourselves to the environmental friendly new energy by learning advanced waste disposal techniques from best international companies and incorporating waste treatment characteristics in China and other countries of the including. We have developed professional waste-to-energy techniques which can recycle and reuse the discarded materials. All emissions comply with relevant regulations and standards, even satisfying the EU standards or even higher standards, bringing huge social benefits. We deliver municipal solid waste to the unloading hall and then store it in the waste bunker. Since newly delivered waste is the high moisture content, it will be stored there for 3 to 7 days. During that period, the huge gripper turns it over repeatedly to make it evenly scattered, and microorganisms in the waste will help the organic waste to ferment, which makes itself easier to combust. There is a facility to extract air from the bunker and send to the boiler to make sure that the bunker is always under negative pressure, which can effectively prevent smelly air from releasing to the outside. In the process of storing the waste, moisture and organic matters in waste will filter out, forming leachate, which will flow into a pool to recycle. In the beginning, leachate flows into the first setting tank, where the precipitate and floater is removed. Then it goes to the adjusting tank where the effluent is regulated. Then it enters the anaerobic tank, in which the organics is removed. After that, leachate, along with domestic sewage and industrial sewage, get transferred to the denitrification tank and nitrification tank by denitriding. At last, the effluent is delivered to the ultrafiltration and nanofiltration recycling system, discharging clean water, which reaches the Class A discharging standard for daily use within the plant, and realizing complete circulation and zero release. After storage, the waste is plunged to the hopper by the grabber and then is sent to the incinerator by the feeder. When it gets onto the first part of the incinerator, it will be dried rapidly under high temperature. When on the middle part, combustion begins and temperature there is beyond 850 degrees to make the waste burn completely, generating thermal energy to heat up steam, which is transported to steam turbine generator units to conduct power generation. When waste gets onto the final part of the incinerator, slag falls and secondary combustion is conducted for burnout. Slag is finally transported to brick factories and used and recycled as raw materials of construction and paving. In the process of combustion, the hazardous gases will be treated professionally and environmentally friendly. When the temperature in the incinerator goes up to above 850 degrees, it only takes 2 seconds to decompose dioxin and there is no dioxin produced again. Then the mixture gases get into the cooling tower to be cooled rapidly, and then are sent to the circling fluidization reactor to be treated at every stage. After the denatration treatment by the spray denitrification absorbent, the oxynitride generates nitrogen and water. After the denatration, hydrogen chloride, hydrogen sulfide, and other acid gases go through the spray treating agent, generating calcium chloride, calcium sulfide, and other solid substances which will fall down to the bottom and get into the ash bunker. After salinization, particulate heavy metals and dioxin will experience absorption through spray sorbent. The remaining gases get into the bag-type dust collector, where the powder will be filtered. The hazardous remains in the ash bunker will form stable composites after the treatment of chelation and solidification. The composites will be sent to the special landfill to be treated. At last, the pollutant emission becomes harmless, protecting the environment to the largest extent. We have been focusing on investing and operating waste-to-energy projects, manufacturing and supplying core equipment for waste-to-energy projects. With strong technical strength and thorough service system, we render our customers with package services of professional consulting, project design and engineering, equipment supply, investment and construction, operation and maintenance. Professional and tailored solutions will be provided. By far, we have invested over 10 waste-to-energy projects, disposing more than 11,000 tons waste daily. Upon completion of the projects, total daily power generation can meet the demands of 300,000